All right, so we are going to be covering 9.2 on sets and compound inequalities in this video. Starting out with some notations for sets. What are sets? Some definitions here. So the first part is identifying elements of a set. So a set is just a collection of objects or things, and each object within the set is they're called elements. And the notation for a set looks like this. You're going to have the elements within a set are going to be surrounded by these like fancy brackets. Those fancy brackets are used to enclose elements of a set. And now there's going to be this notation. You may want to write some of these things down off to the side so you can memorize what these things are. But this right here, it looks like an E, but it's like a curved E. This means that something is an element of a set. And I will, here's an example of it. If you see X and then this symbol, what it means is X is an element of set A. X is an element of A. So that's one notation to know. Another one. And we can also talk about subsets of a set. To write that something is a subset of something else, so like for example, if A is a subset of B, we write it out like this. You say A, and then this notation right here looks like a kind of an elongated C. A is a subset of B. So let's look at an example of something that is a subset. The set of counting numbers. The set of counting numbers can be written like this. You have these brackets at the beginning and at the end. And the counting numbers are the numbers that we use to count regular objects. So we start with 1, 2, 3, 4, and these dots indicate that it continues on in that pattern. So 5, 6, 7, and it continues on forever. So this is called an infinite set because it doesn't end. And this set of numbers is a subset of all the real numbers. So the real numbers contain a lot more than the counting numbers, because real numbers contain the fractions and negative numbers, irrational numbers. These are called the counting numbers, and they don't include all of the real numbers. So it is a subset of the real numbers. So the empty set, if there's nothing in a set, it's also called a null set, and it's denoted by like a 0 with a slash through it, and that means empty set. And then we can do some operations with sets. So this is the next section of topics in this for sets. So a union. Union is denoted like this. If you want to denote that we're talking about A union B, you actually make it's like a U, but it's kind of more of like a stretched out U, more like a horseshoe. And it is the set of all elements that are either in A or B. So union, denoted like this, means or. It could be in either A or B. So this is some notation here. If you have X, remember what this symbol is? It means that it is an element of either A or B. So X is an element of A or B if and only if, which can also be abbreviated like this, IFF. X is an element of A or B, or A union B, if and only if X is in A, or in set A, or X is in set B. It can be in either one of those. And then the next one here is intersection. So the intersection of two sets is denoted like this. So if I want to say the intersection of A and B, I make that same U, but upside down. And that means that it is the intersection of A and B. So it has to be in both A and B. The union was A or B, intersection is A and B. So let's do some examples on how all of this works. So well, let me go here though. X is an element of A intersection B if and only if X is in A and X is also in B. So it has to be in both sets. So we have a set A here, 1, 3, and 5. B is 0, 2, and 4. C is the counting numbers, 1, 2, 3. It goes on forever. What would be the A union B? So what that means is we would determine all of the elements that are either in A or B. So we have 1, 3, 5 in A and 0, 2, 4 in B, and I just wrote them in chronological order. I have 0, 1, 2, 3, 4, and 5. Those numbers are all there in either A or B. The intersection of A and B means which elements are in set A and also in set B. And they have no elements that overlap at all. So that would be when you would use the null set notation. So there is nothing that is in both A, in the intersection of A and B. What about the intersection of A and C? So if we look at that, we have in A we have 1, 3, 5, and in C we have all the counting numbers, which includes 1, 3, and 5. So that what's the numbers that are in both A intersect C would be all the elements that are in A, because those are also in set C. And then B union C, remember what that means again, it means or. What elements are in either B or C? So C includes all of the elements, like both 2 and 4, but it doesn't have 1. I'm sorry, it doesn't have 0. So we have to add the 0 to that set when we're talking about the union of B and C. And we have the dots to indicate that it keeps going forever and ever. Okay, so let's look at another example here. If A is the set of with the elements 1, 2, 3, 4, 5, 6, and let's find, so here we got to determine this notation. C is the set of all values of X, and the X values that are elements of, oh, I missed something here. It's supposed to say, let me rewrite that. X is an element of A, and X is greater than or equal to 4. So when I'm going to back this problem up again. Example 2. So we have our set A, which is 1, 2, 3, 4, 5, and 6. And we want to find a set C, I'm going to go down to here, such that we're going to find all values of X, such that X is a subset of A, and also X is greater than or equal to 4. Think about what notation I could have used instead of writing the word and. I could have used the intersection. So it has to be in both A and it has to be greater than or equal to 4. So the numbers in A are 1, 2, 3, 4, 5, and 6, and the numbers that are also greater than or equal to 4 would be 4, 5, and 6. So set C is this set of numbers 4, 5, and 6 because it is in the set A as well as being greater than or equal to 4. You can also represent sets with Venn diagrams. So the elements that are in A, so we have A over here, and then B is over here, and then where they overlap is in this region right here. So if we want to find all of the elements that are in set A, it includes all of these numbers that are within this circle. So 2, 4, 6, 8, 10, 12. So this is what we have for set A. I want you guys to determine set B. What elements are in set B? And then come back and check your answer. It's all of these numbers that are within this red circle, and I put them in order 3, 6, 9, 12, and 15. And then let's look at C. You have to find all the elements that are in A or in B. So what does that look like? Well, we have to get all the numbers in A plus all the numbers in B and include both of those because they're the numbers that are either in A or B would be 2. I'm going to go in order here. So I did the 2, the 3, I've got 4 in one or the other. The next number 6, and then 9, 8, and then 9, and then 10, and I'm crossing them off so I make sure I get them all, and then 15. So that would be A union B. It's either in A or B, so it's all those numbers. Okay, now the next one is find the set A intersect B. So think about what that means. It has to be in both A and B. So you can think of this word as and, or that symbol as and. So that would be the 6 and the 12. It's where they overlap. It has to be in both the purple circle and within the red circle, which includes 6 and 12. Okay, I'm going to stop for now, and I'll make a second video with the next piece of this, which is on graphing compound inequalities. So in previously we looked at graphing inequalities, and now we're going to look at compound inequalities in the next video.